Good morning, ladies and gentlemen. This is Mr. Rowe. We're looking at geometry, part B. This is lesson 8. We're going to focus on surface area and volume of a cone. So let's take a look at what we got to do with a cone. So here is our first example. All right, so let's break down a cone so we can understand what the parts of a cone are. In a cone, you typically have three numbers that you need to know in order to do surface area and volume. You need to know R, which is the radius of the circle. That's usually something that you're given or that's easy to find. So in this case, R is 5. You also have the height. Now there are two heights in a cone. Let's break them down so we can understand both. The first height that you're usually given is from the center of the circle. So from right here all the way down to the tip of the cone. That is the height of the cone. So in this case, the height of the cone is 12. And then there's a second height. It's called the slant height. It's usually labeled with an L to represent slant height. The slant height is the distance from the edge of the circle to the tip of the cone. So right here, that's that tip. In this case, it's 13. Now we're going to look in the next example as to how to find some of these values if some of it's missing. For now, we got all three values, so all we got to do is find the surface area and the volume. So let's start off with the surface area. Formula for surface area for any cone is pi r squared plus pi rl. Now, there's lots of different versions to see for that, but this is the easiest way to do it. So here we go. We got r is 5, so pi times 5 squared plus pi times 5 times L. L here is 13. So now what are we going to do? We're going to pull out our calculator if we're not comfortable multiplying. And we're going to do this, 5 squared. Now my suggestion is leave pi alone until you have to at the very end. So that's 25 pi. And we're going to do 5 times 13. 65. So then we have 65 pi. And the reason I want you to do that is because it's a lot easier to deal with pi right at the end. So now these are like variables. So this will be 25 plus 65, which is 90 pi. And then if you're asked for a estimate, then we're going to do 90 times 3.14. And so our final answer here will be 90 pi. That's the exact answer, or 282.6. And that would be whatever the units are squared because it's area. All right, so now how do we find the volume? The volume for any cylinder or cone is 1/3 pi times the radius squared times the height. Now, if you think about it, and there are plenty of demonstrations online that you can watch. If you take a cone with the same height and radius as a cylinder with the same height and radius, you could fill that cone up 3 times, pour it into the cylinder, and then the cylinder would be full. So that's why the volume of any cone is 1/3 the same cylinder. Because if you notice right here, pi r squared times the height, that's the formula that we looked at when we looked at for volume of a cylinder. And so 1/3 handles the fact that it takes 3 to fill it up. So here is the formula. So we're going to substitute 1/3 times pi times the radius squared, which is 5 squared, times the height, which is 12. And so we'll do 5 squared times 12, 300. 1/3 is dividing by 3. So that's going to give us 100 pi. And then again, here is where you would want to multiply by 3.14. So this would be approximately 314. And this would be units cubed, whatever the units are. All right, so that's surface area and volume for any cone. These two processes right here. Let's take a look at our second example. Well, what happens if we're given a cone and we only know two of the three values? Well, we have a secondary step that we have to do in order to figure out the slant height. Now, right here, if you kind of think about it, this forms a right triangle, with 8 and 15 being the legs of that right triangle. So to figure out the slant height, I first have to apply the Pythagorean theorem. And in this case, A and B would be 8 and 15. Now let's say, for example, you were given a cone and you were given the slant height and the height. You could use the same procedure to find the radius of the circle. All right, so A squared plus B squared equals C squared. And again, if you're not sure, 8 squared is 64. And then 15 squared is 225. But you can figure those out on your calculator. So we got 64 plus 225. That's going to equal C squared. 64 plus 225 is 289. And then we're going to take a square root, because the last step of any Pythagorean theorem problem is to take a square root. And if you don't know your square roots up to 625, you're going to do second, x squared, 289. And so that would be 17 is C. So that's how we get that third number. So now, I'm going to redraw the cone here. We've got all three numbers. We've got a radius of 8. We've got a height of 15. And we've got a slant height of 17. Let's find the surface area. Surface area, pi r squared plus pi RL. So the radius is 8. So we got pi times 8 squared plus pi times the radius, which is 8, times the slant height, which is 17. And again, don't worry about pi until the end. So let's see here. We got 8 squared, which is 64. So that's 64 pi plus, and we're going to do 8 times 17. That's 136 pi. So now I just need to do 136 plus 64. So that's going to give us 200 times pi. And again, if you want to estimate that using 3.14, just multiply that by 3.14. And so that would give us approximately 628 units squared. All right, so let's take a look at the volume. Volume is 1/3 pi radius squared times the height. And remember, this is the height. This is the slant height. So this number is only used for surface area. This number only used for volume. All right, so we got 1/3 times pi times 8 squared times the height, which is 15. And so now we're going to do 8 squared times 15 divided by 3, just like we did in the last problem. So that gives us 320 pi, which is a perfectly acceptable answer. I would take that as being done, but if you want to estimate it by multiplying by 3.14, feel free. That's going to give us 1,004 and 8/10. And that would be units cubed. So I hope this helps you find the surface area and volume of any cone. If you're still struggling with the content, please let me know in a teacher message, or better yet, make an appointment for a help session.